we need to review partial fraction decomposition, and then we're actually going to end up solving it. Okay? So it seems really weird to begin with, but if I had some fraction, and so far we haven't cared about the denominator, or sorry, about the numerator. If the denominator is x plus 1 squared times x minus 4, how many partial fractions will there be? 3. Each factor gets 1, and then any factor that has a power also gets 1. So I'm going to have a over x plus 1, and then x plus 1 is squared, so I'm also going to have b over x plus 1 to the second. Now I messed up when I taught this yesterday, and we put a linear equation on top. We don't need that. Okay, that was just a mistake. And then x minus 4 also needs 1. C over x minus 4. So this gets a fraction, this gets a fraction, and this gets a fraction. So every factor gets its own fraction, and any factor that has an exponent also gets its own fraction. Okay? What if I had x to the third times x plus 1 times x minus 2 squared? How many partial fractions will there be? 5. I have 3 factors, so that's 3. And then 2 of them have exponents, so that's the other 2. We end up with 5. Okay? So, a over x plus b over x to the third plus c over x plus 1 plus d over x minus 2 plus e over x minus 2 squared. So all 3 factors ended up with fractions, and then the 2 that had exponents also ended up with a fraction. Okay? Now, if the factor is linear, if the factor is an x to the first, then the numerator is just a constant. But what if the factor is a quadratic? Then the numerator would be squared, would be linear, would have an x in it. Okay, so what if I had x squared plus 9 and x squared plus 1 squared? How many fractions will there be? 3. 2 factors, and one of them has an exponent. But this factor is quadratic, which means that the numerator has to be linear. So instead of just a over x squared plus 9, it's actually ax plus b over x squared plus 9. And the next one will be cx plus d over x squared plus 1. And then the next one would be ex plus f over x squared plus 1 squared. Okay? All right, let's just do one more. So let's do x to the third plus, let's just say plus 7 times x minus 1 squared. How many fractions will there be? 3. Okay. The first one is a cubic. So if I put x to the third plus 7 in the bottom, the numerator has to be 1 degree lower. So we end up with ax squared plus bx plus c, and then x minus 1 with a d over it, and then e over x minus 1 squared. Okay, and then there's one thing that I forgot to teach yesterday. If these are improper fractions, if there are more x's on top than there are on bottom, for instance, look at, okay, what page are we on? 872. All right, look at number 11. Number 11 says 2x to the third minus 4x squared plus 7x plus 3 over x squared plus x plus 5. This is a top-heavy fraction, right? There's a higher degree on top than there is on bottom. And the way to solve these, and we're just going to do one, because we're not going to worry about it, so we're not going to do those other three problems. What you end up doing is just do long division, and you'll end up with the remainder, and then you just decompose the remainder. So this is the only time you're going to see it, unless it shows up on a test, but I haven't seen that yet. Yeah. So what we're going to do is x squared plus x plus 5. And then I do division, so I stick this in the box, 2x to the third. What goes up here? 2x, and then I get 2x squared and 10x. Add a column. What's going to go in that box? So 2 and this one need to add to be negative 4. So minus 6x squared, which is minus 6, which gives me negative 6x and negative 30. Okay, this one and this one and this one need to add up to be 7. So 10 minus 6 is 4. So 3x, and those are remainders, right? Because we already hit our constant, so 3x is a remainder, and then this one and this one need to add to be 3. So it would be 33. Okay, so I end up with 2x minus 6 plus 3x plus 33 over x squared plus x plus 5. Okay, and then you would just decompose this. Does x squared plus x plus 5 factor? No. So, what a dumb problem. So you can't even decompose that because there's only one factor, and that factor is x squared plus x plus 5. So what you would do is ax plus b over x squared plus x plus 5. But there is no other one, so what's a? 3. What's b? 33. So if you ever have a top-heavy fraction, you divide it, and then you end up with quotient and remainder, and then you decompose the remainder. So this is actually the decomposed fraction. So we're going to avoid those. Those are dumb. Okay? We won't do them. All right. So what do we do once we decompose something? Okay. Look at number 16. Number 16 says 1 over x times x minus 1. How many partial fractions will that have? Just 2. What are they? A over x plus b over x minus 1. We now have to figure out what a and b are. And it's going to look a little confusing at first, but then it's all going to come together, and it's actually pretty simple. It's a little bit of a pain, but it's not hard to do. So, in order to solve for a and b, I need everything to have a common denominator. What is the common denominator going to be? This. Your original denominator is always the common denominator. Okay? So on the right side, what does the first fraction need in order to have a common denominator? This needs an x minus 1. Can I just multiply the bottom of a fraction by x minus 1? No, I have to do it to the top also. So this is x minus 1. And the second one would be x and x. Okay? Now, everything has a common denominator, which means I don't need the denominator anymore. Right? Whatever that denominator is, let's say it's 10. If I have something over 10 plus something over 10 plus something over 10, then I can just get rid of all the 10s. And if something over 10 equals something over 10 plus something over 10, I just eliminate all the 10s. So I'm going to go through and just scratch out all the denominators. And I'm left with 1 equals ax minus a plus bx. I just distributed the a. Okay. Now, I have an a and I have a b. And I have some variables and I have a constant. Okay. This is the only really tricky part, and once you get the hang of it, it's actually really easy. We are going to build a system out of this information. All right? I'm going to move this 1 to the other side. And I'm going to put it here. Is everybody okay with that? That didn't change anything. And I am going to put 0x right there. Now, I have two variables, which means I have to have two equations. Okay? I will have a constant equation and an x equation. Right? I have a's and b's, and I have constants and variables. So let's look at the constants. Which part of this equation deals with constants? The negative a. So I'm going to write two new equations. Negative a. How many constant b's do I have? None. So I'm going to put plus 0b equals 1. Okay. Now I need an x equation. I have ax plus bx equals 0x. Now, what if I had x squareds? Then I would have a third x squared equation, and there would be c's in it. Okay? So what I've done, I have reached into the equation, and I've yanked those out and made an equation out of that. And then I reached in again, and I've taken those out and created an equation out of those. Because can ax influence 1? No, it has x's in it. And constants and x's don't mix. So I had one equation, and I pulled it apart to create two separate equations. And I ended up with negative a plus 0b equals 1, and ax plus bx equals 0x. Well, what good is this x doing? Nothing. They all have an x. So I can just get rid of them. And now I have a matrix. Negative 1, 0, 1, 1, 1, 0. Now I can put that in my matrix and do RREF and figure out what A and B are. So, go into matrix, go over to edit. This is a 2 by 3. Oh, not a 23. So, negative 1, 0, 1. Oops. And 1, 1, 0. Okay. Then exit out. Oh boy. Maybe. Exit out. Go back in. Find RREF. When you get the answer, yes, you do. Okay. And I end up with A equals -1 and B equals 1. So what's the answer? Well, over here, let's remove all of this stuff again. We were just looking for the correct, whoop, that's not what I wanted to do. We just wanted to know which A and B make this work. So A is -1 and B is 1, so the answer is 1 over x plus -1 over x minus 1. These are the two fractions that were used. Did I? What did I do wrong? Oh, you're right. Sorry. So -1 over x plus 1 over x minus 1. These are the two fractions that are used to create this composed fraction. Yes, this is the answer. So let's do one. Actually, it's a little bit easier to see one of the harder problems. Some of the smaller problems are so simple that it's easy to get it messed up. So let's do number 25. So 25 says 4x squared minus 32x plus 72 over x plus 5 and x minus 5 squared. Oh, x plus 1, thank you. X plus 1, and then x minus 5 squared. Now, I am going to put this on this side because eventually that will be the right side of the equation. Okay, so I don't have to move it over halfway. I'll put the original there. What are my partial fractions? A over x plus 1 plus b over x minus 5 plus c over x minus 5 squared. Why do I not need to do cx plus d? It's a duplicate of a linear factor. So we don't need, it's not a true quadratic in the sense of partial fractions. Okay, so we now need everything to have the common denominator. So the c term is the easiest. What does the c need in order to have the common denominator? X plus 1. Now, do I need to put x plus 1 down here? No, because what's going to happen when I'm finished? I'm just going to erase all the denominators. So really, I just need to worry about the numerators. Okay? What does b need? It needs an x plus 1 and an x minus 5. What do x plus 1 and x minus 5 create when we put them together? X squared minus 5 plus 1 is minus 4x plus 5. Right? Minus 5. Good thing Brance is here. Does everybody understand that? So I put that in the numerator. So b needs an x squared minus 4x minus 5. Okay. What does the a need? X minus 5 squared, which is x squared minus, there's a middle term, 2 copies of -5. So -10x plus 25. Okay, let me stop there. Does everybody understand what I'm doing? I made a whole bunch of shortcuts. Everybody gets where those quadratics came from? All right, now this is going to give me one big long equation, and then I will take that big long equation and turn it into a 3-variable system. So I have a's, b's, and c's, which means I'll have 3 equations. My equations will be a constant equation, an x equation, and an x squared equation. So I write it all out. Ax squared minus 10ax plus 25a plus bx squared minus 4bx minus 5b plus cx plus c is equal to 4x squared minus 32x plus 72. Everybody all right with that? What is my constant equation? Well, I go through here and I yank anything out that doesn't have an x in it. So there'll be a 0. Yeah. You'll probably end up with 0 somewhere every single time you do this. So there is a constant, here is a constant, here is a constant, and here is a constant. 25a minus 5b plus 1c equals 72. Everybody all right with that? Now we need to go through and take all the x's out. So here's an x, here's an x, here's an x, and here's an x. Once I have all of this information pulled out, what am I going to do with the x? I'm just going to throw it away. So the x's tell me which equation the a's, b's, and c's belong to, but the x is not part of the system. And that's where people make mistakes, is they forget that you just drop the x's. So I'm not even going to put them in there, because once you put them in, you're just going to scribble them out anyway. So negative 10a minus 4b plus 1c equals negative 32. And once again, every one of these has an x. But if they all have an x, then none of them need an x. So we don't put it in there. Okay. Now I go through and I yank out all of the x squareds. So here's an x squared, here's an x squared. C doesn't have one, so it's just 0. And then here's an x squared. And once again, once I write them down, they will all have x squareds, so I'm just going to delete them. So 1a plus 1b plus 0c is equal to 4. Now all the hard work is done. We just stick this into a matrix. So this is a 3 by 4. And we end up with 25, negative 5, 172. And then negative 10, negative 4, 1, and negative 32. And 1, 1, 0, 4. And then do RREF. And I end up with A equals 3, B equals 1, and C equals 2. What do I do with those? Put them back in the original. So if we go back up here, we get rid of all that stuff. So we have A is 3, B is 1, and C is 2. Now, what if you put your A and B and C in the numerator of in a different order than I did? You'll still get a 3, a 1, and a 2, and they will still match up with your fractions. They just might be in a different order. So it doesn't matter how you arrange these. Your A's, B's, and C's will be linked to the correct fraction. Okay, does that make sense? Do you want to see another one? So the assignment today is 872A, or sorry, B, and it's 15 through 39 odd, but are there any top-heavy fractions in there? 17, 19. Which one? 31. Nope, it's an x squared squared. So that's x to the fourth on bottom. 33 is an x squared squared. So what would the partial fractions be on 33? So it would be ax plus b over x squared plus 1. Wow, that was beautiful. Over x squared plus 1 plus cx plus d over x squared plus 1 squared. Okay. It doesn't look like there are any top-heavy fractions. So, which makes sense. They're not going to do that to you. I don't know why they did it to you before. So, it's Cynthia. Oh, Cynthia. Okay. Get to work.